Good morning everyone, I am Mr. Ish. We have a video over here. We have four functions: e to the x minus 1, e to the minus x minus 1, minus e to the x plus 1, and minus e to the power of minus x plus 1. These are four separate functions. We have to evaluate them for a common solution. When you're looking at these first two, you know everything is coming here with regards to e to the x and e to the minus x as the basic functions. When you're looking at these, you're looking at minus e to the x, and then here you're looking at minus e to the minus x. You know what these may represent in terms of graph, and allow me to show you. E to the x and these first two right here will have a 0, 1 y-intercept, because that's how they are. That's exactly what it will be. This right here is a reflection of this across the y-axis. It would look like this: 0, 1 y-intercept. Let's look at these two. These will have a 0, minus 1 y-intercept. How am I determining these? Just zero out the x's and see what you get. When you zero this out, you get a 1. E to the power of 0, e to the power of 0 is 1. When you zero this out, you have e to the power of 0 is a 1, but this minus makes it a minus 1. So in these instances, you're getting a 0, minus 1 y-intercept. This is a reflection of this across the x-axis, and it looked like this. This right here is a reflection of this across the x-axis. If that's that, then the reflection of it will look like this, and that right there are these equations. But we're looking at these. How does everything translate with regard to these pluses and minuses ones? Let's show you, and then we'll determine the solution. When you're looking over here at e to the x minus 1, you're looking here at e to the x, but you're translating it down minus 1. If originally these two have a y-intercept 0, 1, once you do a minus 1, this right here will translate to 0, 0 in terms of the new y-intercept. This e to the x will become this right over here, going right here to the origin. E to the x minus 1 is right here. E to the minus x will translate again downward by 1 unit, and you'll see this right here. The origin here is your intersection point. This right over here, which was originally minus e to the x, now we're looking at these two. Well, they have a 0, minus 1 original y-intercepts, but when you do this plus 1, it'll become 0, 0, and then you'll see it. Minus e to the x plus 1 will be this minus e to the x, but shifted up by 1 unit, and it'll look like this, the origin intersection. And lastly, this one right here, minus e to the minus x, which is this one right over here, is going to shift up and it'll go to the origin, and that looks something like this. The common solution for all of these is 0, 0, but we're going to mathematically show this to be the case as well. Here we're graphically showing it, but we have to show it mathematically. Let's label all of these. This one right over here, which I just accidentally erased, is e to the x minus 1. This right here is e to the minus x minus 1. This right over here is minus e to the x plus 1, and then lastly this one right over here is minus e to the minus x plus 1, and they're labeled for you. Now let's mathematically prove that for all of these four functions here, 0, 0 is indeed your solution. The graphs are all here before you, but you see how we had translation and some sort of transformations come into play, reflections. Let's mathematically prove this to be true. A good way for you to do it would be just to pick one and then equal it to the other one. Let's pick this one and we can equal it to that. E to the x minus 1 is equal to e to the minus x minus 1. If you take the minus 1 on the other side, it'll cancel out. You'll have e to the x is equal to e to the minus x. But to properly do it, you should take this onto the other side. You'll have e to the x minus e to the minus x is equal to 0. Do a flip over here, because get rid of that negative exponent. All of this is equal to 0. Do a common denominator. You have e to the x, 1 goes in e to the x times it multiplies with this. You'll have e to the 2x minus 1 is equal to 0. Take this across and 0 it out. E to the 2x minus 1 equals 0. E to the 2x is equal to 1. Now bring in the natural logs. 2x ln e is equal to ln 1. Ln e is always 1, but ln e is equal to 0. 2x is equal to 0, x is equal to 0. And that's how you're getting that. Then you can put the 0 in any of these equations right here and solve for y. If each of these is independently equal to y, you put 0 over here, you get 0. E to the power of 0 is a 1. 1 minus 1 is a 0. You can put it here and you get a 0 as well for your y value. I took these two and I determined the solution mathematically. It's 0, and we know it's 0, 0, because you just plug this back in and you solve for y. Let's take another two group of equations and then let's work with those. For the next two groups, let's take these last ones right here. We have minus e to the x plus 1 is equal to minus e to the minus x plus 1. You know these ones will cancel out because it goes on the other side, it zeroes out. You know the minuses will cancel out because cancel each other out. E to the x is equal to e to the minus x. Take this on the other side, e to the x minus e to the minus x is equal to 0. Get rid of this negative exponent, and you have this. And you know how this is going to work out. You'll have e to the 2x minus 1 or e to the x is equal to 0. You'll take this on the other side, it'll 0 out. You'll have e to the 2x minus 1 equals 0. Take 1 on the other side, you have e to the 2x is equal to 1. And then you know when you do the natural logs, as you saw previously, you'll have x is equal to 0. And then you'll just put that 0 into any of these original equations, you'll get y equals 0, and that will be true. Just take this 0 and put it right here. You have minus e to the power of 0 is a minus 1 plus 1 is a 0. Now this part is done, and it's mathematically showing you that indeed for these four, 0 comma 0, that is the origin, is the solution for these four functions. Now I'm just going to take one of each. You see how these two are clumped together and then these two are clumped together in terms of how they show up on the graphs. Let's just take one of each. Let's take e to the minus x minus 1 is equal to this one right here, minus e to the x plus 1. And now let's solve. When you take this on the other side, you'll have e to the minus x plus e to the x is equal to, you take the 1 on the other side, you'll have 2. 1 plus 1 is a 2. Now do a common denominator here after you have gotten rid of that negative exponent. You'll have e to the x over here, you'll have 1 plus e to the 2x is equal to 2. Now take this on the other side. You'll have 1 plus e to the 2x is equal to 2e to the x. Now we have a little bit of work to do. You'll have e to the 2x minus 2e to the x plus 1 is equal to 0. I just took this back over here and I made a quadratic equation. If u is equal to e to the x, I'm getting a u squared minus 2u plus 1 is equal to 0. You can solve this out, it's not too hard. You'll have a u minus 1 and a u minus 1 is equal to 0, because when you compute this, you get this. U minus 1 times u minus 1 is u squared minus 2u plus 1. In each of these instances, u is equal to 1. But we know u is equal to e to the x. I have e to the x is equal to 1. Bring in the natural logs. X ln e is equal to ln 1. Ln e is just a 1. You know x is equal to natural log of 1, which is a 0. And therefore, we are showing you here that indeed x is equal to 0. And that's done. You just carried this through by means of this substitution right over here. U was equal to 1, therefore e to the x is equal to 1, then x is equal to 0 by means of the natural log. When you put this 0 in either of these equations, you'll get a y value of a 0, and you can test it out. Put x value here of 0, you'll have minus e to the power of 0, which is a minus 1. Minus 1 plus that 1 is a 0. So you are showing here, utilizing these, that indeed 0 comma 0 or the origin is a solution. So that's it for this video. You saw that these four are the functions we evaluated. Each of these is individually equal to y, which you can say f of x is equal to each of these. You have this, you have that, you have that, and you have that. But all of these four have a common solution. That right here is this, your origin. I showed that to you by means of the graph initially, utilizing reflections and translations, and then by means of this algebraic procedure over here. And that's it for this video. Thank you for watching. Have a good day.